Hello and welcome to the section 11.2 lecture today. Today in Algebra 1 Part 2, we're going to be looking at some non-positive exponents. And so for non-positive exponents, what does it mean by non-positive? It means numbers that aren't positive. And so that's going to include 0 and any negative numbers. To make things a little bit easier, we are only going to be dealing with exponents that are whole numbers. We're not going to deal with fractional exponents and things like that. I'm going to save that for a later class. Okay, but we're dealing with 0, sorry, and then any exponents that are negative. So let's take a look at what this is going to give us. If I look at this list, and I'm kind of taking a bunch of powers of 2, the first one is 2 to the 5th power, and we know from the work that we've done that it's 2 times 2 times 2 times 2 times 2. And so if I simplify what that is, granted I could use a calculator, but I'm choosing to make myself think a little bit here. It's 4 times 4 times 2, 4 times 4 is 16, and 16 times 2 is 32. If I think about multiplying 2 by itself 4 times, I really just get the first 4 of these 2's, which is 4 times 4, which is 16. And then if I think about 3 2's being multiplied together, that's 4 times 2, which is 8. And we should start to see a pattern of how to get the next number in my list. Every single time it's dividing by 2. If you don't believe me, keep it going. 2 squared is 4, and 2 to the 1st power is 2. And so we want to divide, we're seeing that if I divide 8 by 2, I get 4. Divide 4 by 2, I get 2. What happens at 2 to the 0 power? Because a lot of people would run and say that it's 0, because why not, I guess. There would be a question as to, well, why wouldn't it be 0? And that's a valid, I hate to say it, but that's a valid question. Why wouldn't it be 0? Well, the only reason it wouldn't be is in order to get the next lower exponent in my list here is that I take the number that I had before and I divide it by 2. So that would make 2 to the 0 power equal to 1. And this pattern actually continues. 2 to the negative 1st power is 1 divided by 2, or 1/2. I guess I wasn't putting arrows there. 2 to the negative 2nd power would be 1/2 divided by 2, which that one takes a little bit of work, but we keep change flip, and it's actually 1/2 divided by 1/2, or 1/2 times 1/2, which is 1/4. And then 2 to the negative 3rd power would be 1/4 divided by 2, or 1/4 times 1/2. And 4 times 2 is 8. And now it turns out that in each one of these, we could have actually written 1/4 as 1 over 2 to the 2nd power, and 1/8 as 1 over 2 to the 3rd power. That's going to come into play in just a second. The rules that we have is a 0 exponent. This one's kind of quick and easy. Any number to the 0 power is equal to 1. Any number to the 0 power is equal to 1. When we have negative exponents, as we see a couple of them here, this same pattern would continue. And it doesn't matter that it's 2. 2 is just an easy number to use as an example. Because if I use 3, then we're looking like 3, 9, 27. Sorry, I'm thinking too much. 81. And then this number gets pretty big, right? It's in the 300s. So, okay, 200s. So I chose 2 because it was a little bit of an easier number to raise to different powers. But if I have a negative exponent, any number to the negative exponent, I'm going to use this idea that it started as 2 to the negative third, and it actually equaled 1 over 2 to the third. So this is going to be 1 over a to that positive n power. Okay? Now the main goal of today is to rewrite things without any negative exponents. We don't want negative exponents, and we don't even really want 0 exponents. We're going to simplify those. And I'm going to kind of leave it to you. I'm going to look at this problem. I'm actually going to look at it 2 different ways. The first way is to deal with the rule that I just stated, that instead of k to the negative 4th power, I'm going to rewrite that as a k to the 4th power on the bottom. And now at this point, I can subtract my k's. I'm thinking about the 3 being set off to the side. And then it would be k to the 7 minus 4th power, which would be 3k to the 3rd power. And now that's right, that's correct. That's using all my rules to their kind of maximum extent. And that's okay. There is another way to do this problem though. I could just use the product property. Okay, so I'm going to move this to the side really quick. And I'm actually going to move it that way. And to do the problem again, I could think of this as 3. When I multiply k's together, that's going to be 7 plus negative 4. And that's actually a quicker way to deal with it. And we notice that I get the same thing. My answer didn't change. So if my answer doesn't change, that means both ways are valid. You kind of usually have to check that multiple times, but consider me having checked it for you. Either way, it works just fine. For this one, I'm going to deal with the a to the 0 powers first because I wrote a rule for that. Any number to the 0 power is 1. So this is going to turn into 4 times 1 times 3 times 1. Multiplying by 1 doesn't really do anything. I get 12 as an answer. There's a couple ways that you could look at this one here. I'm going to look at it, I guess, 2 ways also. I could think to myself, okay, that exponent of 0 has to be shared to everything. Think of it as being airdropped to everything in the parentheses. So that's 2 to the 0, x to the 4 times 0, because this is a power to a power, y to the 3 times 0, and z to the 7 times 0. Well, first thing I'll look at is all those multiplications in the exponents. 4 times 0, 3 times 0, 7 times 0. Anything to the 0 power is 1. And 1 times 1 times 1 times 1 is 1. Again, there's an easier way to look at this. Instead of thinking about dropping in those zeros, I could think, well, whatever this ends up being, I'm going to raise that to the 0 power, and that's going to give me 1. And you can be done right there. In a similar way, I'm not going to do this one 2 ways. I'm going to do it one way that's a little easier than what you might think of. Anything raised to the negative 1 power brings it into the denominator and raises it to the first power. Anything raised to the first power is just what you already had. So this turns into, very simply, 1 over 2x to the 4th, y to the 3rd, z to the 7th. That's it. Sure, you could drop in that negative 1 to everything, but then you'd be moving each piece down below, one by one, and you'd get the same thing. Let's look at some other ones. These ones are going to be a little more involved. There's going to be some more things to do. And we have a lot of problems. I don't know why I kept so many problems in there. But like we've got 8 problems right here to do. And I gave you plenty of room and plenty of problems. So let's jump right into it. The first one. Let's go ahead and deal with the power raised to a power. I need to drop that 4 in to the 2 and the r. So I get 2 to the 4th. R to the negative 4 times 4 is negative 16th. And then on the bottom, I have r to the 5th. 2 plus 3 is 5. I'm going to drop that r to the 16th down below. 2 to the 4th, r to the 5th, r to the 16th. And then I'm going to use my product rule to add those exponents and call that r to the 21st. That's my final answer. It only has positive exponents, and we're good to go. This one, I'm going to do a couple things, I think, right now. I'm going to drop this whole thing. That's 2b to the negative 3 to the negative 1. No, actually, I'm gonna bring that. I'm gonna drop that negative 1 in and do it that way. So I have b to the negative 2, 2b to the 3rd, times 2 to the negative 1st. B to the negative 3 times negative 1 is going to be b to the positive 3rd. And instead of dropping things, maybe I just use my product rule. This one, on numbers wise, I have 2 to the 1st power plus 2 to the negative 1st power, or times 2 to the negative 1st power. So I have 2 to the 1 plus negative 1, and then b to the negative 2 plus 3 power. Typically, I say the negative exponent rule is one of the last things that I do when I actually get left with a negative exponent. 1 plus negative 1 is 0, so this is 2 to the 0 power, so it's 1. I'm not even going to write it. B, I have negative 2 plus 3 is 1, plus 3 is 4. B to the 4th power. My next one here, we can, I guess we'll go ahead and drop these in. Drop the negative 1 in. I have 2 to the negative 1st, x to the negative 4th, times 2x to the 4th. On my 2's, I have negative 1 plus 1. On my x's, I have negative 4 plus 4. And so here, negative 1 plus 1 is 0. Negative 4 plus 4 is 0. So I really would have 2 to the 0 times x to the 0, which is 1 times 1 and equals 1. Okay. On this one, I'll go ahead and deal with the denominator, try to simplify some stuff there before I start moving things up and down. Let's do our power to the power there. 2p to the negative 4th times negative 2 times 4 is negative 8 times p. And that's going to be p on top, 2p to the negative 4 plus negative 8 plus 1. Negative 4 plus negative 8 is negative 12. Negative 12 plus 1 is negative 11. Okay, so now I'm going to take this and I'm going to move it up and give it a positive exponent. I probably wouldn't do this step also. I would probably just combine them and call it good. But now I have p to the 1 plus 11, p to the 12th over 2. Let's go ahead and look at our next ones. This one, a lot of people think, oh, this whole thing is just 1. Well, it's not, because 2 is not being raised to the 0 power. Only the x is. So that x to the 0 power is 1. I have 2. And then times x to the negative first power. All this stuff is being raised to the 0 power, so all that's just 1. Take your x, move it down below, give it a positive exponent. And since the exponent would be 1, I don't need to write it as an exponent. The next one, we'll probably look at the denominator first, try to iron some things out there. I have x squared. Well, y to the 0 is just 1, so I can just write that as x squared. X times y to the negative 2. Let's say we have times 2 to the 4th times x to the 3 plus 4, or sorry, 3 times 4, x to the 12th, y to the negative 4 times 4, negative 16. Let's combine all of our x's and y's in the bottom before we focus on moving anything. I'm going to have my 2 to the 4th first, x to the 1st and x to the 12th is x to the 13th, and my y's would be to the negative 18th. I'm going to move my y up. X squared y to the 18th over 2 to the 4th, x to the 13th. Now here's a little trick. So this is important. If I were to do this correctly, or the right way that it wants me to do it, I would have 1 over 2 to the 4th. My x's would be to the 2 minus 13, and then y to the 18th. But this is going to give me a negative because 13 is bigger than 2. So I kind of use quotient rule here, but I kind of use it a little bit differently. I use it kind of backwards, and I think that there are more x's on the bottom. So I'm going to think about 13 minus 2, and I'm going to write it on the bottom. So I'm going to have y to the 18th on top, and on the bottom I'm going to have the 2 to the 4th, and 13 minus 2 is 11, so I have 11 x's on the bottom. Because if I were to do that subtraction, I'd get the negative 11 as the x exponent, and then I'd have to move it down below. This saves me a step. Which nothing more I want to do in a problem like even this one than save some steps. Let's try to simplify the bottom first. These are about as ugly as I could have made problems. Did it on purpose, but there is a lot of stuff going on. We'll go ahead and drop in that 4 power to a power, x to the negative 4th, y to the 16th, times 2, y to the negative 3rd. Let's go ahead and simplify our y's together on the bottom. Y to the 4th. And I'll put the 2 first. X to the negative 4th is okay. Y is 16 plus negative 3. So that's a 13. Now something weird happens when I look at my x's. I do have to bring the x to the negative 2 down below and the x to the 4 up above. Sorry, x to the negative 4 up above. But if I just think about that as negative 2 minus negative 4, that would be negative 2 plus 4, which is x to the 2nd. So I get an x to the 2nd on top. Y's, I have more on the bottom, so I'm going to only have y's on the bottom. And I'm going to do the same trick that I did over here and think about 13 minus 4, which is 9. And let's look at this last one. Definitely on this one, I want to try to simplify everything I can inside the parentheses before I drop in that 4 on the outside. Because if I don't, that 4 is going to be really busy. I have a lot of things to drop into. So let's try to simplify what we have first. On the top, the first thing I have is a v. I have 3 v's there, 2 v's there, and 1 v there. 3 plus 2 plus 1 is 6. So that's 2v to the 6th, u to the 2nd. On the bottom, I have negative 2 v's and to the 4th power. So that's going to be v to the negative 8th. The v to the negative 8th is going to come up to the top. And really, you could use your quotient rule here. That would work also. But I just think about it coming up to the top, and then I would have v to the 6th and v to the 8th, which is going to be v to the 14th, u to the 2nd. All that's still being raised to the 4th power. We'll go ahead and drop in that 4 now. That's 2 to the 4th, v to the 14 times 4, which is 56, and u to the 8th. All right, if you have any questions, make sure to get over there on the left. Otherwise, I hope you have a great day, and we'll see you in class.